Hello everyone! With this video, I want to introduce you the tutorial of our Incubator project. The tutorial is freely available in our GitHub with the Jupyter Notebook. For the convenient purpose, I have set up the Jupyter Notebook and we will go through that together. As the learning objectives of this tutorial, after completing it, we will be able to first import and use the common Python packages together with the developed AtlasHDF Python module. Second, we will be able to download the OSM data for a given area from the GeoFabric. Then we can set up some customized attribute queries on the OSM data as well as an object filter. Next, with the developed AtlasHDF package, we can do the OSM data mapping, querying, and triangulations into a single data containers. Then we will show you how to use the H5PY to add even raster satellite image data into the existing data containers for future GeoAI applications. There is also a video available to promote our work, and this video is also available in YouTube. As a first step, we first check the Python version of our system and we do the imports of the necessary packages we will need during the tutorials. After this, we will download the OSM data for this Oberbayern regions. For example, we download the latest OSM data in a PBF file from the GeoFabric servers. After we have the OSM data, we can import the AtlasHDF and set up attribute selection queries using the GQ package. The GQ package is a beast together with the HDF5 because it provides a very fast and flexible querying functionalities besides the SQL. Then, in this example, we set up a series of key and value queries, for example, like the nature equals to water or nature equals to wetlands, in order to identify the inland surface water in OSM. After we have set up the query, we can build the object filters, and in the first step, we can apply this object filters to the OSM data. And here you can see within the AtlasHDF, we provide three functions. First, the import immediate to do the immediate mapping of the OSM data. Second, set filters to do the attribute queries of the OSM data. For example, only get the surface waters. Then this resolve will do the triangulations, what we call analysis-ready mapping of the OSM multi-polygons into triangulations. After we successfully run this code, you can see that now the OSM data has been put into the data container. And with the help of the H5PY, we can check what's the data items in the data container and what are their shapes and types of this data set. And then we can close the data container. Next, in this step 5, we can also download some satellite image from the Sentinel-2 with this URL, and we can, with the help of H5PY, we can edit this raster data together with the existing vector data containers. And we can see after we successfully add the Sentinel-2 data, there is a new item in the data HDF5 datasets. After we have write this raster data, we can also read and visualize this satellite image to access it from this data container. For example, with this piece of code, we read this Sentinel-2 data as a NumPy array, and we get the red, green, and blue bands of the satellite image. We simply show the red bands, and then we do the normalization in the bandwise and also to brighten the bands regarding to this RGB channels, and then we can put these RGB channels as a composite and visualize the satellite image. Therefore, you can see with the AtlasHDF, we provide a single solution support for vector data and raster data. Thanks for your time. For any questions, please feel free to reach out to us in GitHub.